for joining us. Did you watch any
What's up?
The prompt engineering game injection?
I did. I was on the edge of my seat. That was awesome.
Yeah. It's pretty cool. I'm going to have to look at it more later. But we are very excited for your talk. Thank you for your patience. And I think without further ado, do you already have your slides?
Yeah, I have. I can share my screen. Let me go here.
That will be the way to go.
Okay. Here we go. You see those?
Yes. Here's your screen that we're seeing.
Yes. It should be the title slide.
Oh, it's like us.
Oh, okay. Let me share. Hold on. I'll share the actual window.
Okay.
Let me try that. Better?
Oops. Yes, that is better. All right.
Awesome.
Cool. Thanks so much. Take it away.
Awesome. Well, thank you for having me. This is super exciting. Today, I'm going to talk about controlled and compliant AI applications. Let's see. Okay, there we go. So I am Daniel Whitenack. I've spent time as a data scientist in industry for quite some time. I've built up some data science and data teams at a couple different startups and an international NGO called SIL International, done consulting at a bunch of different places. And now I'm the founder of a company called Prediction Guard. I also co-host a podcast called Practical AI. If you're into podcasting things, we've done a crossover with the MLOps.community podcast, which is one of my favorites. So check that one out. So in addition to all of those things that I do, one of the main things that I want to do is to integrate the latest large language models into my applications. That's why everyone's here. I've listened to a few of the talks. Everyone's trying some amazing things and accomplishing some amazing things. So I want to join in. I want to integrate the latest large language models. But there's a few problems that I've run into personally. I've tried a bunch of different things with these models. And one of the things that I've found is it's great if you put something into ChatGPT and you get this sort of text vomit output, right? And it's amazing and it's a magical experience. And you immediately think, oh, this could solve so many of my problems. But the fact is that output is also unstructured text and it's fairly inconsistent. And I can't really build robust systems with inconsistent, unstructured text blob output. So if I want to do something, for example, like sentiment analysis, and I don't want to use a traditional sentiment analysis model, I could construct a prompt like this, and I put it into a large language model, and I get out some sort of vomit that looks like the bottom right. So I do get a sentiment tag, in this case, a wrong one, I think. But then I also get all of these other things that continue on. And you might say, oh, Daniel, that's not a problem. You can put like a stop token in, or you can, strip out some of that extra. But I don't want to do that. I mean, part of the reason why I want to use large language models is because I want this magical output that's just right. So this is annoying that I get this text blob output. Also, generally, large language models scare all of these sorts of people like lawyers and finance departments, security professionals, due to a lot of different things. I know already people have talked about in this conference, hallucinations, cost. Most of these language model APIs charge by the token. So you're racking up costs, especially if you're doing use cases like data extraction and other things. There's a lack of compliance in these systems. There's a fear of leaking IP and personal information into commercial APIs where there's maybe suspect terms and conditions around how that will be used. And I love this setup to my talk just now, this game about injection vulnerabilities. So that's cool. That's another thing that's on people's minds. So generally, you have a situation like this. You're in a company. over time, you've created all of this great infrastructure that's all unit tested. It's compliant if you need to be compliant with like HIPAA or SOC 2, Type 2, et cetera. It's structured, it's secure, and you're kind of interacting with a customer. Maybe there's sensitive data there, and all is good. Then you bring in something like OpenAI. And to be clear, I have nothing against OpenAI. Amazing, amazing API and system and models and all of that. But you're going to start making these people like legal and security and finance really unhappy. In a best case scenario, your customer is still happy because they're getting kind of magical experiences that are large language model driven. But everybody else might be having some issues. And in the worst case scenario, you start hallucinating out some incorrect information to your customers, and all of a sudden your customers are now not happy with you as well. So what I want to discuss today is the current realities of dealing with inconsistent, unstructured results. How are people dealing with that generally right now? And then how are people maintaining compliance? What are the various things that people are trying to do? And then I want to introduce my own opinion for a path forward through all of this complication. It wouldn't be a talk at LLMs in production if I didn't provide some opinions and hot takes. So you'll get some of that towards the end. All right, so let's start by talking about this sort of unstructured text vomit output and how people are dealing with that. And I would say that the major ways or the trends in how people are dealing with this unstructured output is via some type of LLM wrappers around large language models. This could be like your own code that you've implemented around large language models that involves some regex or some keyword spotting or filtering or whatever. It could be a framework, and I'll show a couple of those here in a second. Could be like new query languages or schemas even, and custom decoding. So just to give an example of how some of this is done, I'd like to highlight great work by Shreya on guardrails. I think she's talked at this conference before. Amazing work here around using these sort of like XML-like specs to wrap large language model calls and guard those calls to check for the specifically structured output. So you're not getting random text blobs, but you're getting nice structured JSON out. Similar projects around this are Guidance from Microsoft and a few others. But this idea that you would kind of wrap a large language model call and like re-ask for things that you don't get and validate the output, that's one approach that people are taking here. One thing I'd like to highlight about these is they're amazing. They work great. I think both Guidance and Guardrails work great for OpenAI. There's, in my experience, these different frameworks don't work in the same way across all different models, especially if you're using open access models. There's some extra custom integration or wrapping that you need to do to make open access models, let's say like Falcon, work with some of these systems. But this is one approach that people are taking. Another one I'd like to highlight from Matt Rickard is re-LLM or regex LLM. This is, I think, a really cool approach because as opposed to wrapping a large language model and then kind of validating output and then re-asking that sort of workflow, this actually modifies the way that tokens are generated as you stream tokens out of the large language model. So this regex, or there's another version by him called parser LLM that does a similar thing with context-free grammars, where you actually look at your regex pattern, you look at your context-free grammar, you figure out what are the next valid tokens that could occur, and then you mask your output for your next token generation based on that regex or that context-free grammar. So this is really cool. This is another approach. I think in the words of even Matt, when he tweeted this out saying, we have a problem and we introduced regex, now we have another problem. So this comes with its own problem of having to deal with regex or context-free grammar type stuff. Okay, so let's talk about hallucinations. People are trying a lot of different things with hallucinations, but I think some of the ones I'd like to highlight are formulating multiple prompts, doing some type of consistency checks, or actually using large language models to evaluate large language models. So when I say self-consistency checks or consistency checks, this might be something like this, where instead of just providing input like a prompt to a model and getting output, or instead of even making that prompt fancy with something like chain of thought prompting, you actually input your prompt multiple times to a model with a temperature that's higher than it's a higher temperature, so you get some variability, and then you take a majority vote of that output to get some self-consistency on the output. So that's one methodology to kind of rein in some of this variation in the output. That does have maybe some other issues, like how do you compare various outputs that aren't just like single values or numbers or classes or something like that, but they're just text output? Maybe you could compare them with embeddings or other things. Um, Another technique that I was going to highlight was language models evaluating language model output. So this, for example, is an example from Inspired Critique, which is a package and platform from the cool people over at CMU, Graham Newbig and company. And you can use a model that's been trained, for example, in this case, so the BART model that's been fine-tuned to actually estimate the factuality of a reference text and a source text, and estimate the factual consistency between the two. So you could do this sort of check. Inspired Critique also implements toxicity checks and other things. But those are examples of language models evaluating the output. There's some good docs also in the Llama Index docs, if you look to that, from Jerry and company, who have really been thinking more and more about evaluating the output of a retrieval chain or something like that, and comparing it to the context to determine the quality of output. In terms of compliance and those sorts of things, there's a lot of things people are doing. One thing is ignoring the risk, so just charging ahead anyway, and that's a setup for some disaster. Some are putting a full stop on LLM usage, or not allowing certain data to be passed to LLMs. This, of course, is restrictive, and that might even be another type of liability on your company, because you're not able to get the advantage of using LLMs, and the market's kind of leaving you behind. And then there's hosting of private models. I know that's been discussed here. Of course, with that, you have to learn a little bit more about using GPUs and how to do hosting in your own infrastructure and scale that up, which has its own challenges. So here's my sort of opinion about what we should do going forward based on these observations. So I've been trying to build large language model applications for use cases, both for my clients and for my own use cases. And this becomes like exceedingly complicated, because using all of what I just talked about, now I have multiple open source projects, multiple large language models that are evaluating large language models, all sorts of different queries and specs that I have to know, from regex to XML to other things like special query languages like language model query language. I also need to figure out like model hosting and private model hosting. And I have to do that for each model that I want to integrate, because all of those things work differently for different models. So this starts to become more than like a single human can manage, I think. So my opinion of how to move forward within this climate is to create a standardized API for both open and closed models. Open models are then hosted in a compliant manner and integrated into that standardized API. And then some of these things like checks for consistency, factuality, toxicity, and then the structuring of output and output types are kind of brought together in a way where in this standardized API, it's familiar to devs. They don't have to learn a new specification. They don't have to learn a new query language. They just have to know how to make an API call or have to know which type they want on the output. So I'm going to share with you what that actually looks like in practice. Of course, my opinionated take on this is what's represented in the system that we've built in Prediction Guard. So I'm going to show you how that works out and hopefully help you understand why I think this is really useful and can produce a lot of acceleration as you try to build actual large language model applications. All right, I don't know. Let's see. Okay. Okay. So I'm not sure why that's not loading. Let me escape here. I don't know if you're seeing that prompt now, but here's the prompt that I'm going to be using throughout the rest of these examples. It's a Instagram post that I've pulled from my wife's company about candles. And we're going to be using this and making some queries about this post using different large language models. So let me share my screen again, and then we'll just continue on. So in order to do this, I'm using LangChain to create that prompt template, but everything else I'm going to show is with the Prediction Guard client, which you can install, just pip install Prediction Guard. Okay. All right, we'll just show it this way, and hopefully you'll be able to see some of that. So here, some of you might be familiar with the OpenAI API. The OpenAI API looks similar to this. So like you have OpenAI.completion create, and you select a model and then give it a prompt. So here that works almost the same way with the Prediction Guard, actually in this case, the same way. So if we can ask what kind of post this is, and then we get this text output down here. Okay, no dice. I'll share these slides afterwards as well, so people can see them a little bit bigger. So the first thing that we want to do, I mentioned, is create a standardized API for both open and closed models. And the open models can be hosted then in a compliant way, even with compliance like HIPAA compliance. So here we have our Camel 5 billion model, which is hosted in this compliant way. And we can use the exact same API that's OpenAI-like to query this model. What kind of post is this? And we get back some kind of, again, text vomit out of this model, although it looks okay, maybe. Now we want to go to the next phase of, okay, we can use both open and closed models, and the open models being hosted in a compliant way with Prediction Guard. Now we want to start enforcing some of that structure on our output. So here I'm now saying, well, I just don't want any sort of output here. I actually want a certain type of output. I want categorical output, and I want one of these two categories. I want to know if this post is a product announcement or a job posting. And now my output is going to only be one of those two categories. So here you can see my output has been modified, and now I just get one of those two categories on the output. This is a product announcement. I can do a similar thing with other types, like an integer type. So I could ask, how many new products are mentioned, and enforce an integer type on this output. And now I get my output as 2. There's 2 new products mentioned in this post. So right now we implement, integer, float, categorical, JSON, and custom JSON formatted output, all via this OpenAI-like API. Now, just because we can structure output doesn't mean that it is factual or consistent. And so a next thing that we can do is just pull a couple levers, flip a couple switches, and say, hey, I want this output to be integer, but I also want consistency and I want factuality. And just by setting these 2 elements of my output, I can now ensure that when I send this off to Prediction Guard, it's going to ping my model multiple times and check for consistency. It's also going to use a different large language model to check the factuality and the factual consistency between the output and the input. And here I still get success. So Camel was able to tell me how many new products are mentioned with factuality and consistency checked. I could try to fool this and say how many giraffes are mentioned. And if I have those same checks, then I get an error that says inconsistent results. And so I can avoid that sort of hallucination. Now, the last one I'll show here is another one that's a JSON format output. So rather than just doing consistency and factuality checks and type enforcement, we can actually start to get some structured output. So I can say, list out the product names and prices and make that in JSON type. And here we get the text output, but then this is automatically parsed and available now as a dictionary in Python or a JSON blob in the REST API that's returned. So this is how we're envisioning this element of control and compliance with large language models. So we would have this sort of easy to parse output configuration for developers that has types that they're familiar with: integer, float, Boolean, categorical, JSON, custom JSON. We'd also have kind of flip of a switch checks for factuality. We also have the check for toxicity and consistency. And that's kind of our vision of this. As we move to the future, of course, we have a lot on the roadmap. We'd like to make this sort of wrapping and this consistent API with access to all of this functionality available for people's fine tunes of LLMs as well. And we've got more kind of presets of structure and type on the way, along with, of course, more model integrations. So thanks to, I'd like to give a sort of special thanks to, let's see if this loads, special thanks to a lot of people that have inspired this work and even helped out working on great frameworks that have really led the way on this front. So you can find some of them here. All right. So thank you. Again, this is all the places that you can find me on the interwebs and the social medias. Here's a link to the podcast and a link to Prediction Guard if you want to check that out. And of course, I'll be hanging out in the event link and on MLOps Slack if you want to reach out directly.
Awesome. Thank you so much, Daniel. And let's definitely drop some of those links in the chat. Maybe we'll send you over there after if you want to kind of share that with folks as well.
Sure.
Yeah, thanks so much for joining us. I mean, let's give it a minute too to see if people have some questions. I think that like prompt engineering game sort of like absorbed a lot of people, but hopefully they have some good questions. And so one question I have though is like, as you're sort of like doing this work, like, are there things that sort of surprised you that you sort of weren't expecting?
Yeah, great question. So I think the thing that surprised me was I knew that a lot of smart people were working on kind of individual pieces of this solution. And so you can kind of assemble that into something fairly reasonable for a single model. But then as soon as you figure out, oh, that model doesn't work for the use case that I need to do in my next project, then you have to sort of repeat everything again because despite them being like really good frameworks and there's a lot of functionality out there, they all sort of work slightly differently for different models. And so you end up kind of in this loop where you still have to do a lot on this like language model wrapping, custom plumbing around these things, and to get this kind of consistent API and consistent output from project to project.
Got it. Yeah, that's great. And from Sterling Waite, he says, great talk.
Awesome. Thanks, Sterling. Yeah,
good vibes. Cool. So we're also, this is being recorded, so we'll send that out to folks, and then we'll also share the slides. I think maybe Pauline got those from you or we'll get them from you at
Yes.
some point.
And I'm just pasting them into the chat now.
Awesome. Thank you so much. Well, awesome, Daniel. We'll let you go on with your day. We really appreciate you joining us.
Yeah, thanks so much. See you all.